Welcome guys to our today's lesson. We want to continue with our discussion on quadratic equations. Last video we dealt with solutions to quadratic equations using the completing square method. You can check for that video online. This time round we are going to look at solutions to quadratic equations by factor method. Just as a brief introduction, we also mentioned last time that a quadratic equation is an equation of the form x squared plus bx plus c is equal to 0 where a, b and c are constants. And there are several methods used to solve quadratic equations, factor method being one of them. Use of the quadratic formula, which we're going to look at in our next video. Graphical methods, which we're also going to be looking at, or by completing the square method. Here we are interested with factor method. So straight, we want to look at an example. If you have a quadratic equation of the form x squared plus bx plus c, then the first thing that you need to do if you are solving by factor method is to find the product. And the product is always given by the coefficient of x squared, which is a, multiplied by the coefficient, not the coefficient, but the value of c, multiplied by c here, multiplied by that c. A multiplied by c, the coefficient of the quadratic part multiplied by the constant part gives you the product. And then you also need to get the sum. The sum is always the coefficient of b. So let's see how we can solve a quadratic equation by factor method. So with me here I have an example. 6x squared plus 5x minus 6 is equal to 0. So the first thing I get is the product, and in this case my product is going to be 6, this 6 here, the coefficient of x squared multiplied by negative 6. 6 multiplied by negative 6, and that gives me negative 36. Then the sum is going to be equal to 5, the coefficient of b, this value there, the coefficient of x, the b term is going to be a 5. So you are looking for two numbers. Your sum is 5, your product is negative 36. You are looking for two numbers such that the product, when you multiply the two numbers, you're going to get negative 36. And when you add the two numbers, you're going to get 5. That can easily be done by listing down the factors of 36. That is 1 by 36. Of course, that gives 36, but it doesn't add to 5. Maybe you can go and check 6 by 6. That gives you 36, but doesn't add to 5. If I check 9 times 4, yeah, that is 36 again. And this can give me a sum of 5. If I put this as negative 4, so I have it as 9 and negative 4. You realize that 9 times negative 4 will give me negative 36. And then 9 plus negative 4 will give me 5, correct? So now I have negative 36 and 5. Its factors is 5, is 9, and negative 4. So what I'll do, you now come to your equation, come to a equation and you decompose this middle part. You break down that middle part using the two factors that you have there. So I'll write as 6x squared plus, now instead of writing 5, you use down these two numbers, plus 9x minus 4x. Doesn't matter which one you start, you can even start with minus 4x plus 9x, or you can do it the way I've done 9x minus 4x, no issue. Minus 6 should give me 0. So I've now broken this part into 2, so that instead of you see 9x minus 4x will still give you 5x if you decide to bring it together. So now that we've broken two parts, we now factorize. What's common here? I can see 3 is common and x is also common. So I'll write that outside the brackets, and then inside the brackets, the number to put here is that when I multiply this by this number, I get 6x squared is going to be 2x. 3x times 2x gives me 6x squared, correct? Plus 3. So when I multiply 3x times 3, I'll get 9x. You drop down this sign as it is, minus, and then which number is common in those two? You realize you have 2 and there is nothing else that is common, into this will give you 2x. So when I multiply this times that, I get negative 4x. And then this one here, because I've already factored out the negative, so it has to come here as a positive. Positive 3 should give me 0. As a way of checking if my work is correct, note that the value or the figure you have inside the bracket should always be the same. You should not get a different thing inside the brackets. So you can just drop one of them and take this, whatever is outside the brackets. You take whatever is outside the brackets, so I have 3x, and here I have minus 2. That's what's outside the brackets. And then one of the 2 that is inside the brackets, that is 2x plus 3 being equal to 0. Now that's what you have now after a factorization. That's what you have after factorization. This was negative 9 and 4, just in case you want to refer. Now, when can the product of two numbers be equal to 0? This is a group of numbers, When can you multiply the 2 and you get your final answer as 0? It only happens under one condition, when one of them is equal to 0. We don't know which one. So we can say, for us to get a product of these two numbers being equal to 0, then either 3x minus 2 is equal to 0, or 2x plus 3 is equal to 0. So on solving this part, we realize that if 3x minus 2 is equal to 0, then it means 3x is equal to 2. We take that to the other side, observing the plus minus rule, and so it means x is equal to 2 over 3. X is equal to 2 over 3. That gives us our first root of the quadratic equation. When I consider the other part, 2x plus 3 equal to 0, then you realize that 2x will be equal to negative 3, and so that tells me that x is going to be equal to negative 3 over 2. That leaves me with my second root, or I can just write as x equal to negative 1 and 1 over 2. So now we have the two roots for x, or for a quadratic equation. You consider this part equate to 0 and solve for the value of x. Consider this part equal to 0 and solve for the value of x. And that generates for you the two values of x. So basically that's how we solve a quadratic equation by factor method. Get the product, which is given by a multiplied by c, negative 36. Get the sum. Identify two factors that will give you negative 36. When you multiply, and will give you 5. When you add, I got them as negative 9 and negative 4. Decompose that part, factorize, and end up finding the values of x. So let's check what we have in our assignment section. But before we go to the assignment section, there is a comment I've made down here that this method does not apply to all quadratic equations. Some quadratic equations cannot be factorized. Sorry for that. They cannot be factorized. And so you are advised to explore other methods to solve quadratic equations. So this method is not very, I can say very strong in terms of solving quadratic equations. Maybe you need to consider other methods like completing the square method, or maybe by use of the quadratic formula. So let's look at what we have in our assignment section. I have two questions for you. You can list them down and solve them. I've given the answers, the roots to the first quadratic question and the roots to the second quadratic equation. If you find any challenge, feel free to leave a comment, and please subscribe to my YouTube channel for more stuff. Thank you.